Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, I'm Mr. Wheeler and welcome to another episode of Lost in Math. Today we're continuing our work on quadratic functions and we're talking about how to graph quadratic functions without a graphing calculator. So when we graph a quadratic function, we're going to break it up into 4 steps. So let's just get right into it. We're graphing the quadratic function y equals x squared plus 4x plus 5. Step 1, we want to find and graph the axis of symmetry. If you forgot how to find the axis of symmetry, there's a card in the top right-hand corner. Feel free to check it out. But we use a formula. X equals the opposite of b over 2a. So we take a and b from our quadratic function, find the axis of symmetry, math, math, math. So our axis of symmetry is at -2. So we find and plot our axis of symmetry. So I go over to the x-coordinate -2 and draw a vertical line, and I have found and plotted my axis of symmetry. Step 1, check. Step 2, we want to find and graph the vertex. Again, from our last section, hopefully you remember, we plug in our axis of symmetry into our function and get out a y value. So this gives you my vertex, the ordered pair x comma y. So I plug -2 into my function, math, and I get out my answer of +1. So my vertex is at the ordered pair -2, 1. So next I plot that on my graph. And step 2, done. Step 3 asks us to find and plot the y-intercept if possible. It'll always be possible, but sometimes it won't help us. So we might have already plotted it. We'll get to that later. Or maybe my y-intercept is off of my graph, so I can't plot it on the graph provided. But anyways, to find the y-intercept. Y-intercepts, we recall, is where a graph intersects the y-axis. And we'll also remember that every point along the y-axis has an x value of 0. So if I want to find a y-intercept, I know my x value is going to be 0. So I could plug a 0 into my function. And when I do that, I get out y equals 5. So my y-intercept is at 0, 5. A little trick to y-intercepts. To find a y-intercept, you plug a 0 in for x. When I do that in a quadratic function, my a term and my b term will both go away because a is multiplying x squared and b is multiplying x. And whenever you multiply anything times 0, you get out a 0. So your y-intercept will always be equal to the c value of your quadratic function when it's written in standard form. So your y-intercept should always equal whatever c is when your quadratic function's written in standard form. So that's a little trick to speed up the process. So I found my y-intercept at 0, 5. I plot that on my graph. Thanks to the axis of symmetry, the axis of symmetry cuts my parabola in half, makes it symmetrical on both sides. So since I have a dot at 0, 5, I also have a dot there at -4, 5. 0, 5 was 2 spaces to the right of my axis of symmetry. So I should also have a point 2 spaces to the left there at my axis of symmetry. So whenever we find one point on a quadratic equation, we actually find 2 points. Thanks to the axis of symmetry, I can find its partner point on the other side of the axis of symmetry. Step 4 asks us to find and plot other points. On your notes and on your worksheets, I'm going to ask you to plot 5 points total when you're graphing a quadratic function. We have 3 so far, and every time we find one point, we get another point thanks to our axis of symmetry. So I just need to find one more ordered pair. You can pick anything you want for x, but you want to be sure that it is on your graph. So we're going to be smart about what x values we pick. Now my vertex was at -2, and my y-intercept was at x equals 0. So I know that my graph is going to form a parabola. So I know I should get a point on my graph in between -2 and 0. So I know if I plug in a -1 for x, I should get an ordered pair that is on my graph, because it has to be in between those 2 points in that area there. So -1 would be a smart choice to pick. It's not the only choice to pick, but I'm sure that it'll be on my graph. So I'll plug a -1 into my quadratic function. When I do that, I get out a +2. So that means that I have an ordered pair -1, 2. Plot that on my graph. Since I have a dot at -1, 2, thanks to the axis of symmetry, I also have a dot at -3, 2. And now I have 5 points total. So I connect my dots with a nice smooth curve, which should form a parabola. It does. And I'm done graphing our practice problem on the front. So to graph quadratic equations, we got 4 steps. Find the axis of symmetry, plot it. Find the vertex, plot it. Find the y-intercept if you can, plot it, and the other points you get thanks to the axis of symmetry. And then find other points as needed so that you have 5 points total. Connect your dots with a nice smooth curve, arrows at the end, and you're done. So on the back of your notes, you got 2 practice problems. Why don't you go ahead and try those? And here are the solutions to practice problem 1. Come back when things get interesting. B equals 0 on this one. There's no x term, so the number multiplying my x term is 0. That's why it's not there. Interesting thing, kind of. Step 3 doesn't help us at all. Step 3 is find the y-intercept. The y-intercept is at -2. I already found the y-intercept when I found my vertex. My vertex was at 0, -2, so that was already my y-intercept. So plotting it again doesn't help us at all. So now on step 4, since I need 5 points total, I need to plot 2 other points. I need to find 2 more points. Again, you can plug anything you want in for x, but instead of going too far away, I already have a point at x equals 0, so I'll just move over 1. So if I plug in x equals 1, this is what happens. I get out a -1, so I have an ordered pair at 1, -1, which means I also have an ordered pair at -1, -1. So I got 3 points now. So I need to plug in 1 more to get to 5 total. So I already moved over 1 to get to 1 on the x-axis. I'll move over 1 more to get to 2 on the x-axis. So when I plug in a 2 for x, I get out a +2. So I have an ordered pair at 2, 2, which means I also have an ordered pair at -2, 2. And now I have my 5 points total. Connect them with a smooth curve, parabola. So you can try practice problem number 2. And here's all the work for practice problem number 2. I'll come back if anything weird happens. C equals 0. There's no C on this problem, so my C is 0. So that means my y-intercept is 0. So my y-intercept is at the origin, there. There, I'll let you get back to it. All right, and that is how you graph quadratic functions without a calculator. Click like if you liked the video. I'm done for today. Bye, guys. See you next time. Functions, and we're going to learn how to graph quadratic functions. We're stopping that. I didn't like it one bit. Step one, we want to plot the intercept, if possible. Won't always. Right of my axis of symmetry. I also have a dot there at 0. That's our vertex. Is that -2? Hold on. This is all wrong. No. Thing number one, b is 0. There's no 0 term. There's no x. There's a 0. Interesting thing number one, finding our... Here's... Look. So that means c equals 0. So my y-intercept is at 0 on the y-axis. So that's my... All right. That's all. Quick video, maybe. I'm not going to say that. Who knows how long this took.